Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So in this video, we are going to work on a practical. Okay, so we've said a lot about the microprocessor, the microcontroller, okay, microprocessor and then microcontroller, and we've done some videos on the simulation. So in this channel, we are not new to the Arduino, we are not new to the microcontroller. So what we're going to do in this video is a project, a practical. That's our first practical done in our lab here in school. So we're going to do that here in this video, the simulation, and then talk about it. Okay, then other video will go to the next practical and so on and so forth, like that. So and of course I've talked about the site I use Workway and then Tinkercad. Okay, but in this video I'm going to use Tinkercad for it. What we are doing in this first particle is blinking two LEDs with an Arduino. So, and I decided to use Tinkercad because the components we use in our lab, most of them, they look exactly like the one in Tinkercad. The one in Workway, they look like it, but there are some that looks really different somehow, but the same function. So I'm going to use Tinkercad for it. So yeah, now to carry out this project or this practical, the thing is this: what you need to know the name of the particle. That's the aim, the objective. Know that. If you know that, then you know the right connection to make. Okay, you know the right connection to make. After you make your connection, you write your code based on your connection, and then you run it and you write your report. Okay, done. The particles are actually straightforward and interesting. So since we've known that this particle, this first one, is to blink two LEDs using an Arduino, since we've known that, then it's to create the circuits, which is the connection. So you click on create and then circuits. Okay, then the next thing to do is to gather the components. What components do you need to carry out this particle? Okay, so but I think I will just have to name this part first. Load. So while that is loading, what component do you think we are going to need? We said we want to do what? Blink two LEDs with an Arduino. That already spells out components you need. You need what? Two LED. You need another. What do you need again? Arduino. And of course, to connect these guys, to connect them, you need wires, jumper wires to connect. Yeah, thank God. So all right, so before I select the components, let me just name this thing so that it's once you open once the this environment opens up, Tinkercad automatically gives it a name. Okay, so we'll have to just rename it to match what we are talking about. So we say it's blinking what? Two LEDs with what? An Arduino. So yeah, good. Now select the components. We said we need LED, right? One and then two. Good. So blinking two LEDs, that's it. Those are the two LEDs, of which you can change their color if you want. This one be yellow. Yellow funny. Okay, yellow is okay. Then the other one is red. Manish. Okay, then what do we need? We say we need Arduino. So you can't see it here, but you can type it Arduino, and here we have it. Sorry about that. So you have your Arduino there. Okay, then for wires, jumper wires, if you just click, you see wires coming out. That's how this website is built. So thank God for that. Okay, then what else do we need? Of course, we need what? Resistors in order to keep our LEDs safe. So one resistor, one LED, one resistor. So in terms of the flow of current, then we need what? A breadboard. So if you've watched some of my videos where we talk about because we've done some project before, so I believe you've seen how we use the breadboard. It's just like an extension. So instead of connecting the LED directly to the microcontroller Arduino, we'll connect the LED to the breadboard and connect that pin we want to connect the LED to. Connect that pin to that same line in the breadboard. Okay, you will see what we do that now. So that's why we need the breadboard, like extension of our connection, that kind of idea. So let me just rotate this guy so that we'll have more space, because I want to zoom in. Keep them close so we can zoom in. Space for wire. Okay, yeah, I think we're good like this. All right, so now it's time to make the connection. So we have all our components ready. Now the procedure, the thing is this. So we'll connect the circuit according to the circuit diagram. So there's a circuit diagram, okay, provided. Then we'll launch the Arduino IDE, type in and verify. That's type in the code, verify, and then you see we'll do all those stuff here, and then we'll troubleshoot to obtain the result we need. So for the circuit connection, we are connecting the positive leg. Now look at this closely. Let me just put this guy here. Okay, so can we see this now? Now if you put the mouse here, you see that all these lines, they are connected. Same here, all these lines, they are what? Connected. Are we together? So that means if I should connect, now this is the negative because this is the shorter, you can see, cathode. This side is really nice. So once you just go over it, you will see the name, anode. So negative, positive. So this side should be connected to where? Ground. So, and where is ground? This is ground of the Arduino. So you can just click on this ground. Click on that ground. Okay. Click on the ground. Let me put it here. Click on the ground. Plug it here. Now you can see that this guy is not straight. So yeah, straight. Now you can see that when you touch this, all these lines, you see that all they are connected. That's why they are all highlighted. They are all selected, highlighted, because they are all internally connected in the breadboard. So by doing this, let me make this wire black. Black wire is better. So it indicates ground. Okay. So by doing this, it means that whatever that's in this pin, that's this ground pin, is connected to everything here. So by the time I take this negative, this anode, and I plug it to this part, it means I have connected this leg of this LED to where? This ground of the Arduino. Are we seeing it now? Then for our positive, okay, let me connect the negative of this guy also. Connect the negative. So both LEDs have been connected. Are we together? Both LEDs have been what? Connected. Then the next thing is this. The next thing is to connect the Arduino. I connect the live, which is the positive, to a pin in where? The Arduino. Now connect the positive leg of LED 1. Let's call this LED 1, right? I think there's something I can name them here in this guy, in this site. Oh, this LED 2 and this one. Yeah, correct, 1. So we'll connect the positive leg of LED 1 to a digital output pin of the Arduino. So we can connect it to pin 13. Now to do that, what we are going to do is this. Take this guy here and then pin 13. I think I should rotate this guy so that, let me rotate it. We are together, we are together. I'm just looking for a neat way to make the connection. That's what I'm doing. Please bear with me, okay? Put this together. So I'm going to take the wire all the way around. Our wire is long enough. Our jumper wire is long enough. Simulation, advantage of simulation, your wire can be as long as you want. So yeah, taking it all the way around. Bam. Oh, this is not straight. Yeah, straight now. This guy is straight enough. Okay, whether it's straight or not, so it doesn't really mean, but just for aesthetic beauty. So of course, this is going to the positive leg of this guy. So let's make that red. Okay, red, positive. All right, so you can see that this guy is connected. This part, this connection ends here. This connection ends here. However, because we've connected the resistor in between, it now links this side to where this other side. So what's the value of this resistor? This 1 kilo ohm. Is that okay? Let's use 10 kilo ohms. Now it will affect the brightness. When we simulate it, we can adjust the brightness to see what's up. Okay. All right. Okay, it's stated we are using a 1 kilo ohm or 470 ohms. So let's go with the 1 kilo ohms. Let's go with that 1 kilo ohm. Let's go with that. It looks like it should be 1 kilo ohm. Yes, it is. Okay, so the same connection we did for this guy LED1, we're going to do that for LED2. Okay, and we're going to connect LED2. Oh, the resistor here is 220 ohms, 220. So let's work with that. I'm trying to follow our manual. Okay, 220 ohms, 220 ohms resistor. Then the next thing, connecting the positive leg of LED2, positive leg of LED2 through another 220 ohms. So this one should also be 220, 220, 220, 220, 220, and then to digital pin 7 of the Arduino. Where's my pin 7? Where are you, pin 7? Yeah, here you are. So same process, go all the way around, all the way around. I don't want any wire to cross each other. I want it to be neat. Connection I'm making is not much now, so you can afford to be that neat. Okay, better. So we are done, guys. We are done with our connection. Okay, and then the negative leg, but we have done that already. The third thing is to connect the negative leg of the LED1 and LED2 to ground pin of the Arduino board, which we have done already. Negative leg here, negative leg here. We have done that already. Then open the Arduino IDE and then we'll write the code using the digital write function and control to control the state of data output input. Okay, now so let's do that. Where do we have our code? Here we have our code. Okay, so you click on that and you click on text. So are you sure you want to close the blocks editor? Yes, I want to. Any block currently have lost? Yeah, I want to continue. So I'll have the chance now to write my own code from scratch. So we can start by saying code for what? Blinking to LEDs. Okay, so of course this 2 slash means comment. That means when we run the program, this thing will not be executed. This comment is just, as the name implies, as the name, comment, explanatory notes. Okay, for you the programmer or for other programmers who maybe view your code. So the comments will explain what your code means. Okay, all right, so just plug this guy, plug, good. Now so let's write our code. Let's write our code. So the thing is this, we are using pin 13, pin 13 and pin 7, right? So let's do this, saying that first of all, let's say variable declaration. Let me use this declaration. So pin 13, this 13 is an integer, so we say int. And what do we have there? LED. So the LED 13, 13. So this is anything in pin 13, we are calling that one LED 1. Let's put the number there, LED 1. So in our code, once we deal with LED, once we write anything we do to LED 1, this name LED 1 in our code will affect where pin 13 and physically affect whatever is that is connected to pin 13. Same thing to the next thing, LED 2. That one is connected to pin this, okay? So we've done that. Now the next thing to do is to set up the connection. We've done the physical connection. Now what these guys, this line here, they are what? Digital pins. Also pulse width modulation. Okay, so this digital pin, they are digital input and output pin, IO pin. Okay, so should they be input? Should they act as input or act? Should they act as input or act? Oh boy, or act as output? That will be determined by this function called setup function. But this function takes no argument here, and it returns doesn't return a value. So we say it's void. So void setup. Okay, so yeah, let me just put the last part here. All right, so in this void setup, this way we now determine saying what should pin 13 be. Should it be output pin or input pin? Note that we are doing what? Note that we are controlling these two LED using the Arduino, right? That means we are going to send signal to the LED to turn on or off. That means we are sending signal from the Arduino out into the LED. That means this is what? Output pin. Okay, note that they can be either output or input, but now we are deciding that it should be what? Output. And how do we make that decision in our code? You say what? You say what? Pin mode. Pin mode. This is how you write the pin mode, okay? And I've talked about this thing in our previous video where we worked on the past question. Pin mode, LED 1. LED 1. LED 1, I will say that one should be what? Output. Okay, output. Then for the second one, pin pin mode, LED 2, that should be what? Also output. Okay. Okay, yes. Now instead of I know this will turn up. Cancel. Now instead of doing this, we can as well say that comment this guy. We can as well say that instead of writing that part, just come here and say 13, and here is what? 7, isn't it? 7. Okay, have we seen the difference now? Now if you want to put 12 here, that's fine, but it means your second LED, you will now remove it from pin 7 and plug it in where? Pin 12. But in our connection we use what? Pin 7. So here should be 7. Are we seeing it now? So you don't need that top, that variable declaration. You do not need it if you are using the exact pin number here. But if you want to use a name, a variable, then you declare the variable, whether it's a data type, integer, float, double. You declare the variable and then you assign the pin to it. Are we seeing it now? So here we'll close what? Close setup. Okay, so since we've set up the Arduino, now it's time to give the Arduino what should be repeated. That means a loop now, a loop function, and of course it doesn't return a value, so we say what? Void loop function. So I like to just start and close immediately so I know what I'm doing. So this close loop. Okay, so inside our loop function, what are we going to do? we are going to say we are going to send a signal to one of the Arduino, one of the LED, which is, how do we send a signal to, this is a digital pin, note, these are digital pins. So we want to send signal to the digital pins, we say digital. Okay, we want to put something inside, which is, we are sending output, we say write. If we want to get input, like we want to take something from a digital pin, we say what? Read. Are we seeing the difference? For this, I want to send something. I want to send a signal, which is 5 volts high, and we are sending it to which pin? 13. Are we sending high or low? High. The high means it will turn on, it will send voltage to that pin, and once voltage goes to this pin, once voltage goes to pin 13, this pin, this guy will turn on. If we send voltage which is high to this pin, this one will turn on. That's the behavior here. Okay, so let's finish this. Okay, I guess in the next practical video, I will not explain like as deep as this, because it will just be like repetition. So let's just, so we are doing that for the second one. No, for the first one. So now we've turned on this LED. Okay, so turn on let me say red LED. Red LED do what? Lights up. Okay, then we now say what? The same LED low. What's the meaning of this? Think. What's the meaning of this? Red what? Red LED turns off. Now if we do it this way, what is going to happen? The LED will turn on, that's the red one, will turn on, then it will what? It will turn off again. But what about our second LED? We have another one which is in pin 7, right? And that one is what? Yellow. But let's make it green. So it will just match. Let's make it green. I didn't look at that before. Green, better. So red and green, that's okay. Back to our code. So green LED. Perfect. So at this first time in the loop, we are sending high, that's for the red LED to be on, and we are sending low for the green LED to be off. Are we seeing it? So once we do that, we now say delay 1000. This is in what? Millisecond. 1000 millisecond is the same as what? 1 second. The same as 1 second. Okay, so that means for 1 second this red LED will be on and this one will be off. That will happen, that will stay for 1 second. I don't know which other word to use. That will, it will just be like that for 1 second. And after 1 second, what will happen next? We'll now say digital what? Right again. 13 will now turn off pin, low, meaning what? Red LED goes out, or turn off, or whichever one. Let me use goes out here so that's together. Goes out, so that we are speaking the same language. Okay, and then the next thing that will happen is what? We will just repeat the same thing. Digital right. For pin 7, we say what? High. Are we seeing the switch now? So in the first case, so this one now green LED. Green LED lights up. Beautiful. And of course, delay for 1 second. Oh boy, that's 1 second. Hey. Good, 1 second. Okay, and then we'll close loop. We're done. We're done with that. Okay, so this is the end of the code, the complete code. So this one turns on and this guy is off. That's delays for 1 second. After 1 second, this 13 turns off, which is the red LED turns off, and then the green one turns on, and we delay for 1 second. The loop ends and goes back again, turning on this one and turning off the other one. So we've said a lot. Let's just run this thing and see what happens. Are we together? Let's go. What? Miss something? So it's like your code has some errors. For what? Voice setup. Really? Let's see. Pin mode. Okay, I can see. This should be small letter. Oh, typographical error. Oh, all right, noted. Thank you. So I believe we understand that error. This should be like small letter. Okay, that should be small letter. That was just that error there. Another error. How far now? What's happening? I think they should give me the hints. Oh, digital rights. Oh, brother. Spelling. Okay, I think that should be it. I hope we're good now. Thank you. Yeah, I think it's working now. It's working. Excuse me. Good, excuse me. Thank you. Perfect. Light up. Perfect. Are we seeing how beautiful it is? Lights up. And this guy will switch. Thank you. That's it. Very nice. So Arduino practical 1 completed successfully. Okay. So now, of course, what do you observe? Your observation. After spelling pin mode with capital letter O, we had an error. After using digital rights, like you observe that now, digital rights, and we didn't spell correctly, it refused to run. Now this, we are supposed to use if I was using physical Arduino. So let me just quickly show you guys this thing here before I end this video. Okay, it's still running until we say stop. So as long as the Arduino is connected to the computer or connected to a power source, the program runs continuously until you unplug it. So for the simulation, it's just clicking stop, that's unplug. But in real life, as long as the Arduino is plugged to a power source, the program runs continuously. I believe that observation that's obvious. Okay, so you can take your own observation and think of your own observations and things like that. Okay, please let me know in the comment section what you observe, and when you try it out with your own Arduino, like physical Arduino, when you try it out, let me know in the comment section. Come back to this video and say, hey guy, this is what I observed. I've tried this project, I've tried this practical, and this is what I observed. Let me know in the comment section. Show you. This is our verify. After writing your code, let's load that code here. Stop the simulation. So you bring this code. Let's load it here. So load. After loading your code here, you verify. If you get closer, you see the verify. Okay. Oh, this is a different file. It's okay, no problem. But I'm just using it as an example. You verify before you load, before you upload to the Arduino. So this is the verify that was written in our manual. Okay, and once it's complete, once it's correct, it will done compiling and it's okay. All right. So that's all for this video. Okay. So leave your observation in the comment section. You can do that if you want. Let me know what you observe, your results, conclusion, and things like that. Okay. So thanks a lot for watching. and bye for now. See you in the next video.